Okay, this is a video on doing some different probability topics in Excel. Particularly, this should help you with the Excel Lab 3 assignment. So this will be in preparation for the Excel Lab 3 assignment, but just in general, I'll show you some of the different things that you can do here in Excel probability-wise. So let's start with doing probability distribution tables. So a probability distribution assumes that you have different possible values of a variable along with their probabilities. So let's do an example of that. I have an example here where we have some different households and they have reported their number of phones, and then we know the percentage of households for each. So this is something that I think would be really helpful if you haven't made a table like this actually while you're doing these types of questions. This should be helpful also for this topic and your homework questions. So what you're going to do is you're going to first set up the X values as like all the possible things that can be an answer to the question. So in this question, all the possible things that can be an answer to it are 0 phones, no phones, 1, 2, or 3. So if we go over here into Excel, you can put this anywhere on the page. We'll just type X as a label for our X column, and then we'll fill it in with the possible values, 0, 1, 2, and 3. All right, then next to that, we are going to use a P of X column. P of X stands for the probability of each of these happening, each of these answers happening. And a probability can be a fraction, a decimal, or a percent. So in terms of this question, the percents that they gave us for each answer would represent the probability of each of those. So the 1% is going to be the P of X that goes next to 0, and the 11% is going to be the P of X that goes next to 1, etc. But I want to make sure I report them in decimal form or fraction form. I don't want to leave them as percents. So I want to make sure I move the decimals back 2 spots. So 1% here, let me just type P of X as my column label. 1% is going to look like 0.01 as a decimal, right? Move that decimal back to the left 2 spots, or divide by 100 is another way to think about it. And then we have 11%, 31, and 57. So I'm going to just change those all into their decimals, 0.11, 0.31, 0.57. Okay, now our next column is going to be to get X times P of X. This doesn't mean X times a P value times another X. This parentheses here is function notation, and that means the probability of that X. In other words, we're going to take each X value times its own probability, and we're going to put that in this column. Now, when you're doing that by hand, you literally have to multiply. We're going to let Excel be a calculator. We talked about Excel being a calculator for our preparation for lab 2. We're going to use that idea again. So I'm just going to type a label again up here on the top. This is going to be the X, and times on your keyboard is actually going to be the asterisk, which is above the number 8, or it might be on your number pad on the side. So X times P of X, and this is just my label, but that's actually what we're going to do for the calculation as well. Now remember, when you want Excel to be a calculator, we start with an equal sign, and then it knows to do a calculation versus just putting in what you're typing. And remember, we also learned that rather than typing the numbers in, it's better if you click on the boxes that hold the numbers, because then if you have to fix something along the way, it's going to also fix all your formulas. So for the first one, we want to do this X times, so I'm going to use that asterisk for times this P of X. And then once you do one of them, we could do it again if you want, equals this X times its own P of X. Now a little trick that Excel has is you could go down the line, and I realize we only have 2 more to do here, so it's not a long one, but if you had a longer list to accomplish, rather than doing each of them separately, if you go up to the first box and see that little green, extra green square that's at the bottom right of the box, normally your cursor looks like a fat white cross. If you hover over that, it turns into a skinny black cross, and if you click and drag it down, it will repeat that calculation all the way down until you finish your list, until you stop dragging it. So you can see here in the formula bar, this did like that number times that number, and then it did this number times this number, and then it did this number times this number. By the way, I'm in the desktop version of Excel, but you should be able to do everything in this lab also in the web version of Excel if you prefer. It should all be the same. Finally, going back to our table, we have to make an x squared times p of x table. So, or column rather. So the way you do squared in on a keyboard is you're going to do x, and to do an exponent, it's the little caret that's above the 6. So I'm going to do shift 6, so I get that little caret to the second power. So that'll be x raised to the second power times p of x. Now, all this calculation stuff I'm doing right now is a way to help you make it really easy to find the mean, standard deviation, and variance of any probability distribution. There are quicker ways to do this for specific probability distributions like a binomial, but this will help you figure out mean, variance, and standard deviation for any probability set, any probability distribution where all the probabilities are between 0 and 1 and they add up exactly to 1. We're going to check that in a moment. Those are the two properties that you need to make something a probability distribution. Once it has those properties, if you do these calculations here, it's going to make it really easy to find the mean, variance, and standard deviation. So let's finish our table here. We want Excel to be a calculator. We'll start with an equal sign. And we're going to do x raised to the second power, so that I'll square it, and times its own p of x, not times the column right next to it here, but times its own p of x again. So we go back to these two original columns. And we'll get 0 once again, because 0 squared is 0 times anything is 0. But if we drag down our numbers, it'll do in this one. You can see the formula up here. This 1 squared times 0.11 is 0.11. Here, 2 squared is 4. It's doing that. Times 0.31 is 1.24. You could double check it by hand if you want, but those are correct. And then what we're going to do is I'm just going to type a label here for totals. We don't need to total up the x's. And we're going to total each of these columns. So a quick way to do totals is if you go into your formulas tab, and you can just click this sum, auto sum. And if it guesses wrong, you can make sure you tell it which ones to add. We want to add all the p of x's, for example. And when you hit enter, it'll add them all together. And you can do that for each column here. Or you could do that drag thing. It actually works when you drag it across as well. It'll add up all our columns for us. So why do we do that? Well, we want to make sure the p of x column adds up to 1 exactly. Otherwise, we don't have a probability distribution. So one of the tricky things that's going to happen on your Excel lab is, for some of you, you're going to have a little bit of trouble getting started. You have to think through what are going to be the x's and the p of x's for the scenario that I give you. And one way to check to make sure that you're on the right track is to add up your p of x column and make sure that you get 1 there. Okay, so that's a good tip for you. Now, after that, the cool part about doing one of these tables, and again, you can use this for your homework problems if you haven't done it this way yet, is when you finish this x times p of x column and you total it, that is the formula for finding the mean of a probability distribution. Let me go back in these notes here, I'll show you. The mean or expected value of a probability distribution is the sum of all the x times p of x values. That's what we just did there. We found all the x times p of x values and we added them. So no additional calculation needed. Don't go in and use that average function. That's for a list of descriptive data from a sample. This is not a sample. This is a population. This is like all the possible things that could happen. And so we can't use that average that's built in here. What we can do is know that if we do each x times p of x and total it, that number is our mean. We can just copy it over. It's all done. Now the 6.48 here is not your variance, but it gets you very close to it. That is going to help us, because if we add up the x squareds times p of x's, which we did, that's the 6.48. All we have to do is subtract from that the mean. Remember, this is the symbol for mean. We have to subtract from that the mean squared, and that'll give us the variance. So again, we're not using the built-in variance function here. That will not work correctly. But what we are doing is we're going to make Excel be a calculator. We'll start with an equal sign. We're going to take the total of the x squared times p of x column, and we're going to subtract the mean. You can click on it up in the table or here, it doesn't matter. The mean squared. Remember how we did squared caret 2. So I'm doing equals the total of the last column minus the total of the third column squared, and that'll give us the variance. And then finally, the standard deviation, again, we're not going to use the built-in standard deviation function. It will not work. But what we do know is that whether we're talking about, sorry, this is for the next part, I keep clicking to the wrong PowerPoint there. What we do know is that standard deviation is just the square root of variance. So we can do the square root of variance. Remember, if you go into your insert function and you look for SQRT, it's like square root without the vowels. That's how you can find a square root. And you just, okay. And click on the one number that you want to take the square root of. So we want to take the square root of variance. And that'll give us the standard deviation. Okay. So you can use this process anytime you're trying to find the mean, variance, and standard deviation of any probability distribution. A probability distribution is when you have all the possible things that can happen along with their probabilities. And the probabilities are all between 0 and 1 and add up to exactly 1. From there, you can make a table. The total of your x times p of x is always your mean. The total of your x squared times p of x column is the start to your variance. We just have to take that number and subtract the mean squared. And then we're going to square root that number to find the standard deviation. Now, if you want to round these numbers, remember, you just go to the home tab. Don't round it in your head and then retype it because it'll get rid of your formula. We're going to go into the home tab and we're just going to use this decrease decimal to say we want 2 decimal places for all of these. We're going to just use that to decrease the decimal. It'll preserve our formulas and it'll round your decimals correctly as you go. So that way, when I go into your lab file, I'm going to go into the formulas tab and click on show formulas. And I'm going to want to see this formula work in here. That's part of following the lab directions, is having this formula work. That's what I mean by the control page, the formula page, because if you hover over this, you can see the keyboard shortcut is control and the accent mark. So if you hold those two down, that's why I call it the control page. That'll also toggle your formulas back and forth. All right, so that is part 1 of your Excel Lab 3 assignment, but also, again, how you can do any probability distribution, find its mean, variance, and standard deviation within Excel here. You're not using the built-in functions, you're just using it to kind of do these calculations for you. So the first part of your lab is you're going to recreate this using all the possible values when you roll a pair of dice and their probabilities to find the mean and variance and standard deviation in that scenario, and then talk about what these values tell you. So in this case, the mean of 2.44, remember X was like the number of phones we have. So having a mean of 2.44 means that on average, these households have about 2.44 phones. So most of the households have 2 to 3 phones on average. Some are more, some are less, but that's our average. The variance doesn't mean too much on its own, but it helps us get the standard deviation. And that's sort of like, we wouldn't be surprised if we were higher or lower from the average by that amount. It's like our normal spread of values. So, you know, going down about 0.73 or up about 0.73 from the mean means that's, you know, where we find most of our values. If we round them even more, it make more sense to you. Like say the mean was 2, most households have about 2 phones. Give or take, standard deviation is about 1, give or take 1. So most households have between 1 and 3 phones, for example. And you can see that is definitely true. There's only a small amount of households that have not something in that range. All right, the second part of the lab then is once you build this table, you're going to use the probabilities in this table to then do some additional binomial calculations. So I'm going to show you some built-in formulas for binomial calculations. So let's use some of the examples I have here to do some binomial things. So this one talks about we're taking 8 shots at a target. We normally hit the target 70% of the time, and we want the probability that she hits the target exactly 6 times. So no matter if you're doing this by hand, in a calculator, in a computer, using the table, when you're doing binomial, you should always be thinking about these questions. So first off, I think, is this even a binomial experiment? Is there only 2 possibilities? Are the results independent? In other words, you know, each time you take a shot, is it a new fresh start? I think so. You know, each shot doesn't affect the next one necessarily. Does the probability of hitting the target stay the same every time? Yep. Is there only 2 possibilities? Yeah, we can either hit the target or not hit the target. So it's got all the properties. So what is a success? I put success in quotes because it doesn't necessarily have to be a good thing. Like we think of successful as good. It's just what it is we're trying to do. So in this case, we're trying to hit the target. So that means a success is hitting the target. So what is that helpful for? It helps us figure out what P and Q and N and X are. P stands for the probability of a success. So in other words, what's the probability of hitting the target? 70%. Q is the exact opposite of that. So in this case, the probability of not hitting the target, which would be 30%. When you're doing this in Excel, though, you won't need the Q value. It's going to be able to automatically figure that out based on the P that you put in. Next up is the N value. N is the number of times that you hit the target. And this, or sorry, let me say that again, because I said that backwards. N is the number of total times that you're doing the experiment. So in that case, it would be the 8 shots. We're trying this 8 times. Each time is a chance to hit the target. And then X represents the number of successes. So in other words, how many times do we want to hit the target? That would be the 6. All right, so we've got that determined. We're going to keep track. I'm just going to put some labels here so then I can save this file and show you. So in the dice example, and I'm going to put it in a particular order. Let me show you what the binomial function is going to look like for just a moment here. We're going to go into insert function and we're going to type binom dist without, just like an abbreviation of binomial and distribution, all one word. When you hit go, you should see it here. So this is the built-in functions under formulas insert function. It's going to ask us for 4 things: number S, trials, probability of success, and cumulative. Okay, so keep that in mind. All right, so number S, the first box is the number of successes. That's like the X value. Number of successes, we call that X. Some calculators use R for that, by the way, or if you're using the NCR for the binomial calculations. All right, next up, it asked us for the number of trials. So the number of trials, let me make sure I'm telling you this right, because I have a slide with the Excel stuff here. So first it asks for the number of successes, which is the value of X. Then it asks for the number of trials. That's going to be our N value. How many total times are we doing the experiment? So the next thing I'm going to need is the N value. I'm just putting a label right now. Then it's going to ask me for the probability of success. So that's going to be the little p value. What's the probability that we hit the target in this case? I keep wanting to put the plus, not the equals. Then the last thing it's going to ask you for is if you want it to be cumulative. So we'll talk about that in a second. I'll just put it with a question mark. Do we want it to be cumulative? All right, so let's start with X, N, and P. We know what those all are. Go back to my example. Remember, X is the last one that we thought about. How many times exactly do you want to do get the experiment, the success to happen? In this case, 6. Then number of trials is like how many total times are you doing the experiment? In that case, it's N, which is going to be the 8. And then probability of success stands for the little p value. In other words, what's the chance that you do that success? What's the chance we hit the target each time? 70%. So I'm just going to record all those numbers here again. So we want 6 times that we hit the target out of 8 total trials, 8 shots, with a 70%. I'm just going to write it as a decimal. You only want decimals or fractions, not percents, just like I did with this table up here. So 70% as a decimal is 0.7. All right, now the last thing it asks for is being cumulative. You don't need a Q value. Cumulative doesn't stand for the Q value either. Cumulative, we're either going to tell it yes or no to this question. The word cumulative, think of when we did cumulative frequencies, means a running total. So in other words, it's asking you if you want to total up anything. In this case, what it's asking you if it wants you to total, let me go back down to my Excel slide here, is it's asking you if you want to total up from X equals 0 successes up through the X value that you put in as a cumulative answer, where you don't have to do each of those separately. If you want just one X all alone, not a mix of X's together, then we call that an exact value, in which case we don't want cumulative. We want to say, no, don't add anything. So in our case here, we don't want it to add anything. We just want X equals 6, just that exact number of successes, not like more or less successes than that. So for the cumulative box, Excel's way of saying yes or no is true or false. So in the case of here, we want it to be false. we don't want it to add anything. It doesn't mean that you're doing like an opposite probability or anything like that. It literally just means we only want this X value. We don't want any other X's mixed in with it. So don't add anything. Saying false to the cumulative means don't add anything. So let's figure out our answer. You can put it wherever you want. I'm just typing a label here. We're going to go back into that function. We're going to pull up that binomial dist function I just showed you. And it's got those things here. Now I purposely put the labels and the numbers in separate boxes so I can go ahead and click on them here, or you could just type them in, it's okay. So number of successes, you can just type the 6 or click on the 6. I did put them separate because if I put all together X equals 6 in this box, it wouldn't like me to click on it. I would have to just type the 6 in here. It only wants a number, okay? Number of trials, that's the 8. Probability of success, that's the 70%. I turned it into a decimal. And do I want it to be cumulative? Nope. I can type false in here. I could click on my false that I typed. When you hit OK, it will give you the answer. You can double check that answer by hand or using the binomial table, and you should get the same thing. So this is telling me there's, if you rounded it, almost a 30% chance of her hitting the target exactly 6 out of 8 times. And you might think that sounds a little bit low if she has a 70% accuracy, but not really, because we're asking for like the probability of that specifically happening, not her hitting it, 5 or 4 times or 6 or 7 or 8 times, exactly 6 out of 8 times. So it's like a very specific scenario that we're looking for. So that is our answer. Another thing you might have to do is, I'm going to go to what I have labeled as the third example here. I'm going to show you how you can use that cumulative. So let's look at this example. We're checking for defective products and the chance that a defective product is 0.01. What's the probability that no more than one defective product out of one, there is no more than one defective product out of 100 inspected. So this is binomial because our two possibilities are it's defective or not. Each product is a new fresh trial that doesn't affect the last product, where the chance of it being defective stays the same the whole time. So all those things are met with binomial. So a success in this case, since we're checking specifically for defective products, that's our success, finding a defective product. I know that sounds weird. That's what makes that kind of a weird term, because you might think, well, that's not successful. I don't want to find defective things. It kind of is in this case, right? Like we're trying to pick out the defective products and find them. So our success, it doesn't matter if it means something good or bad to you. It's just, what is it that you're looking for? We're looking for defective products. So what's the probability of finding defective product? 0.01. What's the opposite of that? It would be 0.99, but we don't need that in Excel. How many trials are we doing? Well, each product that we check is a trial. So that would be 100. And then how many successes do we want? No more than 1. So let's talk about that for a minute. No more than 1 means 1 is like our top. We don't want to find 2 or 3 more than, we don't want to find any more than 1, 2, 3, 4, etc. So 1 would be the most we want to find. That would be our X. However, we could also be happy if we found 0 defective products. So when you see the phrase no more than, it means that we're going to check that number and below all the way down to 0. So we have more than one X value here, 0 and 1. Okay. So let's put all that in, and I'm going to put it in the order again that the formula is going to ask. So just kind of the same stuff here. And actually I can just make my life a little easier. I'm going to copy and paste these. All right, so the X in this case, remember we just determined was going to be either 0 or 1. Not like we choose one or the other, but we want to include both of those. When you're doing multiple X values and you're doing this by hand or with the table, you're going to look up each X value or calculate the answer with each X value and then add them together. And that's one way we could do this. We can do it just like above here where we do false. And we could first put in just X is 0 and find that answer. And we can go back to the formula and then just put in X is 1 and use false in both cases and find that answer. And then we can have Excel just add the 2 answers together. That's totally fine. Much more helpful if you have to do even like a few X values. So you had to do X's like 0, 1, 2, 3, 4, 5, 6, 7, something like that. Then what we would want to do is definitely do it the way I'm going to show you here, where we use the cumulative to make it easier than doing them all separately. All right, so our number of trials, remember, was 100 because we were checking 100 products. And the probability of success, remember, was 0.01. And I am going to say true to the cumulative. Why am I going to say true? Well, remember that means we want it to add up from x equals 0 up to the x value that we put in. Well, if we want to include x equals 0, what we're going to do is we're going to put the highest x value in our list, which is 1 in this case. You might have a problem where it's a higher number. Put in the highest x value that you want. And if we put true in the cumulative box, it'll include 0 all the way up to that number x that you put in there. And it's going to automatically do every one of those separate calculations and have it added all together, all in one shot, where you don't have to do them each separately. So it's a nice quick way to do several x values at the same time, starting at x equals 0 up to whatever x value you want. So you'll notice I went back into my formulas, insert function, binom dist. We have number S, so number of successes. Now I can't click on the 0 or 1 here, but I just talked about, I want to put the highest x value in. So I'm going to type in the 1. 100 trials, I can type or click on that. 0.01 is my probability of success. I can type in or click on that. And I do want it to add this time. I want it to find x equals 0. I want it to find x equals 1. It'll stop at 1 because that's what I put in here. And it'll add it all together for me and give me the final answer. So there's about a 74% chance of finding 0 or 1 defective product. That's pretty good. I like that number here because that means that mostly we don't have defective products, right? So that's a good thing. All right, last example here, and this is kind of the tricky one. We talked about both situations of cumulative, but there's one more type that you might have, and that is something like this example. So I'll call this the dice example. We're going to roll a die 6 times, and we want the probability that a 2 is rolled at least 4 times. So this is binomial. You might not think of rolling a die as binomial at first because you think, well, there's 6 different sides, not just 2. Well, the fact is we can either think of it as like rolling a certain thing or not rolling that. So here we're trying to roll a 2. That's our success. So the opposite of that would be not rolling a 2, rolling any of the other numbers. That's why binomial comes up so often in real life stuff, because there's so many things that you can break it down to either like you get that thing or you get anything but that. And that's how you can make it 2 possibilities. Each trial is independent because each time you roll the die doesn't affect what happened before it. And every time we roll, there's the same chance of getting a 2. In fact, that chance, little p, is 1 out of 6, right? Because 2 is 1 out of 6 numbers on our die. So little p is 1 out of 6. Little q would be 5 out of 6. Like what's the chance of not rolling a 2? Rolling any of the other 5 out of 6 numbers, but we don't need that in Excel. It's going to do that in the background. Number of trials, n. That's our 6 rolls. Each time we roll the die is a chance of getting a 2. So 6 is going to be our n. What is x? Well, we definitely want to involve the 4, rolled at least 4 times. However, let's be careful how we use it. People think of the word least as lesser, but the phrase at least means this number or better. So say, for example, I told you I want to get at least an 80% on my exam. You would not be happy if you got a lower than 80% number. So at least doesn't mean lower. At least 80% means like that's my minimum, and I wouldn't be happy if I get less than that, but I would be fine if I get higher than an 80. So same thing applies here. At least 4 means we'll be happy if we get a 2 to come out 4 of the times, at least, or more. So 5 times or even 6 times would be fine. And we stop at 6 because we're only doing 6 rolls. So here, for our dice example, and I'll just copy this one more time again. Our x is 4 or 5 or 6. We want to get our 2 to come out 4 or 5 or 6 times. Number of trials, 6. We're doing 6 rolls. Probability of success is 1 out of 6. Now, I'll show you this because this might come up when you're doing fractions earlier. You can put a fraction in here, it's fine. It might think it's a date though. So like when I put 1/6, see how it makes it January 6th? I don't want it to be a date. So it just guesses at what you want. If you go back to the Home tab, you can go to, why am I not seeing it? Oh, here we go. You can go into this kind of middle area where it says number custom. This is your formatting of your cells. We can click on any cells that we want to put fractions in, and we can put a number if we want it to like specifically be a number. It'll convert it to a decimal, or we can even put that we want to keep it as a fraction. But that'll keep it away from thinking that it's a date automatically. So I'm going to put fraction. And now when I put in 1 out of 6, it's going to keep it as a fraction. It's not going to try to convert it to a date. And you can actually see it's decimal up here too. It's thinking of the decimal in the background. All right, now, do we want it to be cumulative? This one's a little tricky. The answer is yes, kind of, right? Because we want to have it add 3 different x's together. So cumulative, yes, we want to add. But cumulative always assumes you go from 0 up to a number. So if we put in 4, for example, it's going to give us x is 0 to 4. That's not what we want. We want 4, 5, or 6. The same thing would happen with 5 or even 6. If we put 6 in and say yes to the cumulative, it's going to add from 0 to 6, but we don't want all those. We only want 4, 5, and 6. So one way you can do it is there's not that many numbers here. You could do them all separately. You could do just x is 4 with false, x is 5 with false, x is 6 with false, and then separately add them all together. You gotta make sure you do false though, so it does the exact just 4, just 5, just 6. Or I'll teach you a little trick here where you can use the cumulative to your advantage. So how will we use it to our advantage? We are going to make the computer do the opposite of what we want. So what is the opposite? The opposite means what x values do you not want. Well, if I'm rolling it 6 times and I want to try to get 4 or 5 or 6, what x values do we not want? We don't want 0. Actually, I'm going to do this one more time here. I don't want 0 or 1 or 2 or 3, right? Those are the x's I don't want. I want to just keep 4, 5, and 6. I don't want to get 0 2s or 1 or 2 or 3 of them. I want to try to get 4 or 5 or 6 2s. That's what the question is asking me, at least 4. So I want to take away 0, 1, 2, and 3. Hopefully this is already becoming clearer to you. N is going to be the same. It's still 6 rows, and P is still going to be, let me format this so I get a fraction. Still 1 out of 6 chance of getting a 2. But now when we say cumulative, it's like this question that we did just beforehand. It does involve adding from 0 up to a number. We can get it to do 0, 1, 2, and 3 all at once by typing in the highest x value in the list. We're going to do that, which is 3. And we are going to say true to the cumulative. And it will add from 0 to 3 for us. And we will get what's called the opposite answer. I'll show you how that's going to help us in just a moment. Bear with me. Okay, so let's do this calculation right here. So I'm going to go to my formulas tab. I'm going to go back to my binom dist. So my number of trials, or sorry, number of successes, remember, won't let me click on this because I put multiple numbers in here, but I'm just going to type the highest only x in there, which is the 3. I'm not typing the 4 or 5 or 6. Sometimes the temptation is to type the 4 in there because that's like where our list started. But here's what we're going to be doing with it. We are going to be getting the opposite answer, and opposites in probability add up to 1. You can always find the opposite of what you want and then subtract it from 1 to get the answer you do want. And sometimes it's easier to do probabilities that way when it's easier to get the opposite answer, which it is in this case. So by subtracting, it's kind of like eliminating those x's. So when I find this answer and I subtract it from 1, it's going to eliminate x's 0, 1, 2, 3 and leave 4, 5, and 6 for us. And that's how we're going to get the right answer. If I had put 4 in this box, when I subtract it, 4 is going to get eliminated and only 5 and 6 will be left, which is not what we want. So you got to almost kind of like back off 1 so that you leave the numbers that you do want on the upper end. Hopefully that makes sense. So the number of trials is 6. We're taking 6 rolls. The chance of a success is 1 out of 6. And you can type 1/6 in this box and it'll recognize a fraction. You can see it thinks of it as a decimal, which is fine. And we do want it to be cumulative. So we'll say true because we want it to add 0, 1, 2, 3 all in one shot. Then we don't have to do them all separately. And this number that we got here is the exact opposite of what we want. In probability, exact opposites add up to 1. So let's go back to our actual answer box. We're going to start with an equal sign so that we make Excel be a calculator. And we're going to do 1 minus our opposite answer. So it's going to subtract 0, 1, 2, and 3 from the possibilities from all 100% of the possibilities. That's what the 1 represents. And when I subtract that, it'll leave for me the chance of getting 4, 5, or 6 of them. It's a very small probability you see here, not even a 1% chance. And that should make sense. If we're only rolling a die 6 times, you expect each number to come out once. For one of those numbers to come out 4 or 5 or 6 of those times would be a pretty unusual circumstance. It'd be pretty unlikely. So that's why it corresponds to a pretty low probability here. Remember, you can see all the formulas in here, and I'll share this file for you guys so you can work along with this example and look more at the example and the formulas later. Remember, if you click the show formulas in the formulas tab, you'll be able to see all the formula work here. You might have to make some of these a little bit bigger so you can see the full binomial formulas. But you can see then, you know, what numbers I put into that formula in what order. That's the first box, second, third, fourth, etc. One last thing, it's not for the lab itself. So this is what you're doing on the lab is one of these tables, and then you're going to answer some binomial questions. Not for the lab itself, but just an extra probability thing you can do in here that you will see come up eventually. It'll be in the following week, is normal distributions. If you go into your formulas tab and to insert function, there's something called the norm dist. That'll do normal distributions for you. I believe this is also in your lessons information. And this asks you for a particular data value, a mean, and a standard deviation. And we're always going to put true for cumulative for this one. It's like the binomial, but you don't have to think about whether it's true or false. And again, let me reiterate, because this is a common misconception. Cumulative in the binomial doesn't mean like if you want something or its opposite. It means do you want to add or not. Now we did just do an opposite calculation and we used cumulative there. But it doesn't mean like this one was false because it's the opposite of true. So be really careful about that. Those are kind of two different questions. Doing an opposite probability and whether or not you want it to add are two different things. So anyway, here cumulative is always going to be true, but this will find a z-score for you. So you can put in any x value, a mean, a standard deviation, and put true, and it'll get a z-score for you. Z-scores are going to be helpful for the next type of probability that you're going to do, the normal probabilities. There's also another function called the norm s dist, almost the same abbreviation here, but just an s in the middle. There's some different ones, but it's the one with the s in the middle. And this one is you can put any z-score in and get the probability or the cumulative value to the left of that z. If you haven't looked at the next week's lessons yet, that won't make any sense to you, but when you get to it, you'll see that this is another way to find probabilities associated with z-scores besides using the table that you'll have access to. The table is perfectly fine as well, but I just wanted to show you that Excel has also a function that you can use. And this will tell you the value probability area to the left of any z value. If you want the area to the right, you just find this number and subtract from 1 at the end, kind of like we did with this one here. You can find the area between any two z values. You put in the z, you go into another box, put in the other z, and then in a third box, subtract the bigger minus smaller. So those are some helpful quick tips that you can use for doing normal distributions in Excel. This again is not on your lab. That's why I just went through that really quickly. It's not on your lab assignment, and you can do this in other ways using a table, for example, that will be provided to you. But I wanted to show you that there's a couple extra probability type built-in functions or formulas that you may want to check out in Excel. So I hope this gives you a little bit overview of some of the different probability stuff you can do in Excel. It should definitely help you with the Excel Lab 3 assignment and kind of get you on the right track with some different probability stuff and give you a little extra practice with the probability questions. I will share this file for you guys. You can watch this video as many times as you need, stop and take notes, rewind things, pause things, work along with me. Definitely reach out if you have any questions as you're working on Excel Lab 3, especially if you're having trouble getting started or you want to make sure you have the right X and P of X values before you go any further. Send me your file ahead of time and I will definitely check it out for you and give you some feedback on it before you do your final submit. All right, I hope everyone has a great day, great week, and I will be back again with another Excel video for Lab 4 coming up soon.